Yeah.
Take the,
Real cheese.
let's have a look at this thing right here, parasitic drains. And we talked, you guys had a little bit of experience with parasitic drains the other day, so you kind of know what that's about if you have to find out why the battery is going dead overnight. And that's as old as cars, pretty much, you know. All in the olden days, all you had to do whenever that wiring schematic you see on that 64 Chevrolet, the whole wiring schematic was on one page. You know, it wasn't really all that bad. There wasn't a whole lot back then that could kill the battery unless you had a glove box slide on or something like that. And, I actually killed the battery on my Taurus one time while I was off between semesters because I opened a glove box to get something out of it and I was driving my truck. And when I came back to get it, you know, that wasn't one of the things that the battery saver cuts off. But anyway, we're going to talk about this. But a battery is like a reservoir of electricity, sort of, and the electrons want to be on one side of the plates that are submerged in the electrolyte. Now what you got right here is you got 6 2-volt cells. You know, even a 9-volt battery like you buy at the store has got a bunch of little, you know, 1.5 volt, it's got 6 1.5 volt cells in it. Well, this has got 6 2-volt cells in it, and you got a 12-volt battery here. So that's a cell, that's a cell, that's one, that's one, that's one, that's one.
Are those the ones that sting your toe?
Huh?
Are those the ones that sting your toe?
9-volt battery.
Yeah, the 9-volt battery, yeah. And you can actually, a watch battery will stingle your tongue a little bit too. It's only got 3 volts in it. But they can only travel through the electrolyte or through a direct physical connection. The electrons aren't going to travel unless they have a path for travel, right? So when they all get to the side where they want to be, the battery's dead. They want to go to the other side. Whenever you put a battery charger on it, you're pumping those electrons over on the side where they don't want to be.
So basically, you're not pumping anything into it,
You're basically
changing.
moving electrons.
Yeah.
Yeah, the electrons are being moved from one side of the plate to the
Does
other.
that apply to all batteries, or
Yes.
standard, or
Yes,
general, or
that's all of them.
AGM?
That's
all
all,
of
that's
them?
all of them, yeah. So we want to go to the negative. We'll say they want to go to the negative side, but who cares which is which? It doesn't matter because you can't see electrons, okay? Not a big deal. You can argue with people about that all day about whether power flows from positive to negative or negative to positive as far as electrons, but that's conventional theory versus electronic theory, and that's a bunch of, just don't worry about that because you don't need to know that to fix nothing. Well, let's turn the battery so the ground's at the bottom. There's 6 12-volt chambers here, and each chamber is perfectly sealed so no power can move unless there's a connection between the plus and the minus side. Now these are the big posts or terminals that you can see right here. So sometimes a bad battery will have internal short in here that will cause, you know, have internal short circuit. We'll talk about that a little bit later. I have actually seen somebody pull up there and shut off a vehicle, and when they went to start it, it wouldn't start, and when you pop the caps off and you look down in there, you'd see one cell just boiling to beat the band. It was shorted internally. Well, once again, electrons want to go where they would rather be, on the other side of the plates. When we charge a battery, we're forcing them to go to where they don't want to be. It's kind of like a windmill pumping water against gravity into a big tank. The water wants to go back where it came from, but it stays trapped unless a path is provided. And that's basically what we're talking about there. Now this would be like your battery, that's your storage tank. This is a battery charger, that's your windmill. Your windmill's got a little crank on it and it's moving up and down here and it's pulling out of this reservoir. Well, ultimately, no matter what you do with this water, it's going to wind up back down there sooner or later. It's a hydrological cycle. So whether it's rain, whether it's river, or whether it goes out in the sewer or whatever, it eventually winds up back down here and it gets purified on the way. When a path for flow is provided, if there's not something like an alternator or a battery charger working to keep the electrons moving in the right direction, the water tank will eventually be empty and the battery will be dead. All the electrons will be where they want to be and they're satisfied. They're not going nowhere. Okay? That's the thing. All right. So, when the path for flow is provided, you got to have something. In other words, like the battery charger, you got to be pumping it back, put it back up here. See, that's where I was going. Now, current can't leave the battery on the positive side without a return path. If there's any break in this anywhere, no current will flow. If there's really high resistance anywhere, no current will flow. Now, you remember what we had the other day? You got 12 volts and 10 amps. You got 10 amps and 0 volts. There's no voltage over here, but there is amp. Amps are always flowing in a circle, but you're not going to measure any volts over here because this is your reference point. You got it? Now, if you use that for a reference point, whatever happens, you're going to get some volts. You know, that's why you hook your test light over here when you check it for a ground, because you got to, go to a different reference point in order to find it. Amperage remains constant throughout the circuit. Now, every load on the vehicle uses some electron flow to do work. This is a water wheel. Make magnetism, produce heat and light. Some use more than others, right? Some electronic components have capacitors, which are little reservoirs that actually store electrons for later release. And when a path provided through a load, the electrons can go where they want to be and work can be done along the way. Batteries that are totally dead can actually be charged backwards. You can hook it up, you got a battery completely dead, you can hook a battery charger up to it backwards and charge that thing backwards. Can you imagine what kind of havoc that makes on a car with electronics on it? We used to see that a lot in the early 70s, so most country folks had a trickle charger. And they would have a battery that's completely dead, and they just take the battery out, and they would go ahead and do it. You ever hear anybody talk about not setting a battery on concrete? Why?
Or on just plain dirt.
How come?
But it-
What's the bottom of the battery made out of?
Plastic.
Will plastic conduct electricity?
But it's
What does it do?
natural electrons in the ground, so.
I will tell you this, though, if you go to a place where they sell batteries, they won't usually have them stored on the ground.
They're not.
Not usually. They're sitting up on a rack or something. Anyway, we connect the headlight bulb to the battery on the bench and kill it completely so we could charge it back the right way. That was back in the mid-70s at that Gulf station we worked at. Used to see it fairly regularly. Like when their batteries charged back. And the way they knew it, when they went to put a battery back in the car, the tractor or whatever, the diodes in the alternator were turned so that it would let the current, and they go to put it up, well, we charged it up backwards, they didn't know, they weren't paying attention to which post was which. You don't see that a whole lot anymore because most people don't really work on their own stuff anymore, you know what I mean? All right, this is from a GM TSP when a battery's dead. Using about 40% oh wait a minute, hold on, I got something else I got to give you guys. Don't go anywhere.
I'm gonna get some tests.
I meant to give this out first thing. Take one and pass that around. That's a test everybody needs to fill out while they're doing it. Short answer test. If you're not paying attention or if you're playing with your phone, you probably won't get these answers right. All right. Using up about 40% of the total amp hours will usually take a fully charged battery to a no-start condition at moderate temperatures of 77 degrees. So you put a typical battery in a storage situation, depleting the available amp hours by 20 to 30 amp hours will result in a no-start condition. There won't be enough there. Now, AH refers to amp hours. Most of us talk about cold cranking amps. We don't talk about amp hours. Now, amp hours is something you can see on the side of some of your batteries that you use for other things, like your little remote control car batteries. They'll have an amp hour rating on them. They don't use cold cranking amps on that. But a good tester can tell you how many cold cranking amps the battery has left in it. Batteries tend to lose their ability to store power over time. Every kind of battery is that way. They lose their ability to store power over time. You got that? Even the ones in hybrid vehicles. Pay attention to those, because you'll get the answers to every single one of those questions in the course of this, but they're not in order, okay? So you got to be paying attention. About them there amp hours and cranking amps, two different measurements. A 120 amp hour battery can deliver 1 amp for 120 hours, or 2 amps for 60 hours, or 3 amps for 40 hours, or 4 amps for 30 hours. You understand the math? The basis of it is 1 amp for 20 hours, and you do the math on down. See that? It's basically going to reduce it every time you go. So you're basically going to go in, from that into that, 2 into that, 3 into that, 4 into that. Cranking amps is the number of amps a lead acid battery at 32 degrees can deliver for 30 seconds and maintain at least 1.2 volts per cell.
Hold on, you gotta hold on.
Yeah.
Yes. 120 amp can deliver 2 amps, 60 hours.
You got that? Got it? Reserve capacity is the number of minutes a fully charged battery at 80 degrees Fahrenheit will discharge 25 amps till the battery drops below 10.5 volts. All right? Okay, so if losing 40% of the amp hours would drag this battery below the point that it'd start the car, you can see how a parasitic drain, if it's leaking that water out of that tank, you're going to wind up with the tank too low to do you any good, right? And you might see the sticker here. See the sticker? 55 amp hours. What's that stand for? What's this say?
Reserve capacity.
Reserve, and then cold cranking amps at 0. It'll be a little higher at 32 than it will at 0 because they measured at 0 and 32. All right, now, Some of the electronic modules on vehicles over the past 20 years have banks of capacitors that need to charge up when the battery is first connected. This right here represents a bunch of little modules, right? A capacitor is like a little battery that stores the charge, but only for a few seconds. As a matter of fact, I got a capacitor in that drawer there, or in the office or somewhere, I can find it. There's a bunch of little capacitors. You can buy those things at Radio Shack. And you can take it, they're polarity sensitive. They got a positive and a negative, just like a battery. When you hook a battery up to one of those, like you can take a 12-volt battery and hook it up, you know, to the negative and the positive in the right polarity, and it will store that voltage. And then when you hook up something, it'll tell you that voltage is there, like a meter or whatever. It'll read the voltage, or you can hook an LED up to it the right way, and it'll go boom, and it'll go off. But it doesn't take but a second. The ones that they use on air conditioning units are these great big ones that are like gigantic, and you can load one of those things up with 210 volts. And whenever you take a wooden handle screwdriver and short to its two terminals, it sounds like a shotgun going off. Bow! It's really loud, you know. So anyway, there are drains there. If you don't want all the capacitors to discharge, you can power up the system from another source before disconnecting the battery. Now, it takes 3 or 4 hands if you do this, trying to hook up your jumper box while you're holding your meter in place and all that kind of stuff. But you can get one of these. It's a cool little tool. One of the Motor Age contributors put this picture in there, and I borrowed it from him. This right here goes to the jumper box. You know, the jumper box has got a cigarette lighter plug on it. Now, you're of all people most dumb if you take this and plug it into the cigarette lighter on the car and plug this into the port on the same part. You're going to plug it into your jumper box, and then you're going to plug it in there, and that's going to provide power and ground through pins 16 and pins 4 and 5, and it's going to keep that electrical system alive so that all the capacitors hold their charge when you take the battery off. There was a Mustang that came here one time that belonged to a lady on the campus, in a 2010 model. She said she was having trouble, she didn't know, but she had a battery draw, having to jump it off and all that. So I took the meter, and I took the battery cable off, and I hooked it up, and we were reading a fairly significant drain, but I said, let's walk away for an hour. We walked away for an hour, we came back, and all of the capacitors and the modules had charged everything up, and it was down to no draw. And so we tested the battery, and the battery turned out to be no good when I put the battery in it. All right, this is what we used to do a long time ago. See that light's burning just real dim? We used to take the battery terminal and connect the light in a series like this. In other words, we put a terminal on here so that this would hang on to it. And then we lay this aside so they're not touching. And then we let the current would flow through that bulb. Wherever that load is drawing that current that's not supposed to be drawing it, it's going to cause that light to light up. The only problem with that is, and I've seen this myself, sometimes the draw will be flowing through 2 fuses, and the meter's connected. The read amps works a lot better because you get an exact reading. Like sometimes when you do it in the meter, you may see 2 or 3 amps or something like that, or a couple of amps, and when you're pulling your fuses, it may drop to like just under an amp. Say, that fuse was one of them. But you can't usually tell that using a dadgum light. It's real iffy. Now see, they notice these folks right here were actually using like a bulb that pulls a little more current than a test light. All right, there's some basic rules that are followed by just about every vehicle, but you need to have a wiring schematic ready. Yeah, sometimes that thing takes a click, and sometimes it don't. All right, a wiring schematic is crucial. You got to have a wiring schematic. If you just go in there trying to wing it like Jonathan likes to do, you get in trouble sometimes. All right, you might notice right here, you've got a big fuse here. See, that one is drawn like a little wider. It's got a 30 amp big fuse, a little big one. And notice how it's feeding a whole bunch of fuses down here. All right, let's say that you were pulling your fuses one at a time with your meter connected, and when you pull that particular fuse, none of the other fuses made a difference. You pull that one, and all of a sudden your meter, your draw goes away. All right, now you've got all of these you got to worry about. See that? And plus whatever else is fed by that, it's over here on the other side. So after I find that, I'm going to put that back in. I'm going to put my meter where I can watch it, and I'm going to start pulling these, right? And when I pull the one that's feeding it, I'll say, aha, let's go into my trailer camper adapter. And then I go back there, and the doggone trailer lights are on for whatever, you know what I'm saying? So basically, that's what you're looking at there. And this is the one that I drew. This is a generic layout with our battery over here with a ground there. Battery feeds an underhood junction box with big fuses, little fuses, and some relays. Everybody's seen that on these trucks out here we work on. And each large fuse may feed several smaller fuses in the interior box. That's what we were talking about. Notice I got a relay there, I got some relays out here, I got a bunch of electronic modules here. All right, now watch really close because this picture's gonna change. All right, see that? Write this down. Most manufacturers allow up to 50 milliamps. 50 milliamps is what most of them allow. If you've got more than 50 milliamps, you got an issue. And if you've got just something as simple as the coil on a relay, I've actually seen this lady had a new battery in a motorhome, and she had a coil on a relay that was energized, but the relay wasn't even feeding anything, but it would kill the battery in 2 days. She left her motorhome partner for a couple of days, it'd kill the battery. All right, so anyway, you might notice each module's got its own ground, and some of the modules have capacitors in them and some of them don't. This is the way that I drew that. Now, this is where you're gonna put your meter. Yeah, this, you might notice this is a great big fuse, it's like a 175 amp one or whatever, you know, and it's feeding the fuse block and all that. So you measure your amps right there. Everything that is going anywhere on this vehicle is gonna be flowing through that. How would you call that meter? I mean, how are we connecting that meter? Is that parallel or is that series? It's in series because parallel would have it hooked between here and here, wouldn't it? So we're hooking it up in series and we're letting the current flow through there, we're reading the numbers. All right, without the handy tool, if you've disconnected it and you insert your meter, you gotta allow the capacitors and modules time to charge up, and that can take an hour. Connect your meter to read amps and then go to work on another job. When you guys were doing that the other day, you might notice when you first hooked your meter up, you were showing some current and it dropped down, and then it dropped down again, all by itself, because it was charging up those capacitors, right? You understand that? Okay, now then, we're gonna keep pulling our fuses and stuff until we finally track this down and we find the guilty module. Right there. And this is the little guilty guy, we busted him, right there. See, he's the one. But you have to be able to track that down. That is a module that, in our particular examination, he got busted because he was the one that was leaking voltage. Now, the circuit boards on these things can leak voltage. I've actually seen them just leak 8 or 10 volts, just leak it through. You know, and they cause electrical problems in other parts of the car, because I've actually tracked them through all kinds of stuff, you know, and actually found out that one particular, like the gem module, would be going through a coil on a relay and going somewhere else and causing not just a parasitic drain, but other problems like that. This is what it looks like on a car. Now, this particular vehicle, the battery is mounted somewhere else. But if I can get this right here, this is one we did out here. All right, I gotta turn up. Okay, this one here has a draw. We got that meter set up to read how many amps is going out of the battery. She's got a problem. Well, after we pulled all the fuses, what we found out was when we pulled the stop lamp fuse, the draw goes away. We still got a little too much. So we put it back. Most of it comes back through that. So now what we got to do is find out what it is that the stop lamp switch or stop lamp fuse feeds besides the stop lamps, because they're not on. The stop lamps weren't on, so we had to go keep digging. Yeah. All right, the battery was mounted away from the engine compartment, and the connections made it the primary feed to the junction box. So the big wire that goes to that big post on your junction box, it's got a big old wire. You can take that one loose, and you can hook it up there. See what? That's what we were doing there. Now, back before electronic control modules were used on vehicles, there was a no draw once the headlights, accessories, and ignition switch were turned off. But there had always been glove box lights, and trunk lights, and bad radio. And today we got module leaking current through their electronics, and many of their other guys. What you doing? Huh? Your book? What?
My brake.
Oh, your brake? Okay. All right. Yeah. Close the door so it don't get hot in here. All right. Sometimes the acid crud on the top of a battery can drain it. You ever seen this sticky, that wet gummy? I mean, not gummy, but wet, sticky sweat on top of a battery, right? If you take your meter and you hook it to ground and you touch the top of that battery, you'll see voltage there. And if you see as much as a half a voltage, it'll clean the battery. I have actually, personally, I saw a Thunderbird that came in on the hook one time for a dead battery, and there was a pile of ants about a half an inch deep that was going from one post to the other. Dead ants. And they're through their bodies it was carrying the, you know, but ants are sort of tripped out by electricity. They love to go where relays are. Anybody that lives in the country has had your pump quit working because of ants getting between the relay coils, right? All that kind of stuff. All right. So anyway, this right here, you see this guy, when he's measuring this one, he's actually measuring like 7 volts on there. All right, if your meter reads even a half a volt when you're measuring surface drain, it needs to be cleaned while you're checking the battery. Don't forget to measure voltage drop between the battery post and its terminal while starting the engine. Too much resistance can prevent a battery from charging properly, not to mention increase the amount of current needed to start a vehicle. Some batteries can short out internally. How do you tell? Let's say that you've checked and checked and checked for parasitic drain. Now sometimes I'll grant you this, you've got to leave your meter hooked up and walk away. And the next morning you may come back and find out that a draw has come into place overnight that wasn't there when you left that afternoon. I mean, if you can do that, it works really good if you've got a digital storage oscilloscope too with a, you know, and you can set it up to capture that. But one way or another, what if you found out you don't have any parasitic drain but the battery's still going dead overnight? How can you do that? How can you find out what's going on? How can you eliminate the battery itself? If the battery dies when it's disconnected from everything, the battery itself is a reason for the drain. Seen them do it, but I mean, if you got to make sure. What we used to do at the Ford place is we would take the battery cable off and leave it all night. And if it didn't start the next morning, we know it was a battery. If the battery was charged up and we took it off, and the next morning nothing was connected to it, and you see that because they'll have little voltage leaks on the inside. Now I've got one of these things that is similar to this. It's not exactly like it in there in my desk drawer. It's a high current relay battery cable switch and a wiring diagram, usually all you'll need. See, if you put this on there, then you can basically do your test very easily. I can show you that on the one that I got better than I can describe it from this. You can buy one of these things on Amazon. Pretty handy to have. Okay, look for powertrain codes with your scan tool. Write them down if there's any that may be a clue. Loss of communication or network codes. You're looking for whatever codes you may see in any module that says they can't communicate with other modules, because a lot of them have their own power and ground circuits, but they rely on other modules or ignition switch inputs to wake up or power down. Sometimes they don't power down and they keep trying to talk to other modules. When a module that should have gone to sleep stays awake and keeps talking, we call that a babbling node. These modules will also keep sending out state of health messages to other modules, and the scan tool can help you find the babbler. When other modules are powered down and don't respond, the babbling node sets a loss of communication code for the module it couldn't communicate with. It just sort of gives you an idea of which way you're going to go. Also, if you see aftermarket accessories, this kind of nonsense under the dash, you might consider disconnecting your aftermarket module and watch the meter and see if it's the aftermarket accessories that are doing that. And one time I saw a Jeep that was cutting off. It was just cutting off. And I got under there and I saw a bunch of this stuff, and the guy that had put it in there at some window tint shop or something had cut the main wire going to the ignition switch to put his anti-theft system in there, and he hooked his stuff in there with these big yellow butt connectors. And whenever, you know, it was bouncing around and there wasn't even staying in there good. And so I went ahead and just put it back together with another butt connector so that it would stay. And so it belonged to a plastic surgeon, and he got the guy from the window tint shop to come over there and stand there and talk to him with, you know, so we could talk back and forth. And I said, why is all of these wires wadded up in a big ball and just shoved up under the dash? You know, doesn't that look, you know, you see a problem there? And the guy said, well, you know, I said, you're supposed to run them through a loom or something? And he goes, well, running them through a loom, you get into bending wires and stuff, and it's just not really a good idea, you know. Anyway, but just to verify that that was what the problem was, he cut the wire while the engine running that I said was the problem, and it killed the engine. And see, and so he wound up, by me, yeah, he wound up, you know, putting it back together and fixing it and everything. But anyway, you can be challenged by doing this, but you inspect the battery and check the terminals for voltage drop and correct accordingly. Make sure, you know, don't go in here. If you got a nasty, nasty battery, this is all covered up with crud and everything, that's the first thing you need to straighten out. I mean, come on. You know, if you got bad connections there, all bets are off anyway. If you've just disconnected the battery and connected your meter, give the modules time to charge up. On late model cars, it may take as much as an hour. All right, so I like to disconnect the alternator we've seen that recently here. We had one that had a parasitic drain, and whenever we were looking at it, it's pretty considerable. We unhooked the big terminal from the alternator and the drain went away. And a bad diode will cause that. If it's easy to do it first. Why not? You know what I mean? Because what we did was we pulled every dadgum fuse on that car and there wasn't any change. And so, but when we took the alternator, the big wire off the alternator went away. Also, if you've got wire harness that plugs into the alternator, sometimes the voltage regulator will short out internally and it will kill the battery by keeping the stator powered up all the time. I've seen that before.
Let me ask you this, on that red truck, the alternator went bad and we got another one and put it on there and it worked, you'd be driving down the road and it'd be working and all of a sudden, it just stopped working.
Yeah.
Like you could tell the lights would go dim,
Yeah.
what's
Well, usually there's something wrong inside of it, you know, that's, you got a cold solder joint on or something. There's usually something wrong with the regulator or the brush fit. It depends on who rebuilt it and all that. You know, you need a reputable rebuilder that's gonna rebuild your alternators. Like I did a Motor Age article one time for, a 13th issue on Vistion's rebuilt alternators. And one of the cool things about Vistion is they actually measure the slip rings on the spinning rotor. You know, so they can tell that if they're worn down, a lot of the other manufacturers just throw the brushes in there and build it as cheap as they can. You know, but I've actually seen them also that when you rev it up, the centrifugal force would cause the alternator to go full field, and it would peg out and go 18 volts or whatever. Well, you got something. If you put a lot of the times at some of these parts houses, you have to get 3 or 4 good alternators to get one good one. I mean, so that's not unusual.
Can't you rebuild an alternator?
Huh?
Can't you rebuild one?
You can if you've got enough parts around. The problem with that is you better get good parts to rebuild it with, because I've actually seen that. I've rebuilt them and all that, but I've also bought the parts to rebuild when I found one part bad that I had bought, and then you got to tear it all back down again. You know? All right. I like to disconnect the alternator. All right. Anybody learn something you didn't know before? Everybody answer all your questions.
the surface drain? How do you find the surface drain?
Huh?
How do you find the surface drain?
You got to take your meter and hook it to the negative battery terminal, touch it to the top of the battery. That's how you find your service drain.
Oh, you talking about, okay.
Yeah. Current can't leave the battery unless it's got a path to ground on the other side.
And current can't leave the battery on the positive side.
Unless there's a path to ground on the other side. In other words, you got to have a complete path, complete current path. That's the only way.
Got it.
Got it? All right, everybody knows where to put those tests and put them in that box out there. And, let me turn off my camera there quickly. I want to wave at my YouTube.